All right, in this video, we're going to be working on week 3, day 1. Okay, so let me get to my day 1. All right. So the first question says to evaluate. It gives you an expression and 3 questions, and you fill in the table. So let's go ahead and do, let me just put this in here, week 3, day 1. And we're going to do question 1 through 3. So my expression is x plus 4, and the table they give me is this. Okay, number 1, number 2, and number 3. So those are our questions. And it gives us x values of -2, -2, -1, and 2, and it wants the result. So if I plug these numbers in for x, what am I going to get? What is it going to equal? So let's do the first one. I'm going to put -2 in for x, put it in parentheses until you evaluate if you need the parentheses. I don't need them here, so I'm going to ignore them. I'm going to go -2 plus 4, and that is going to equal a +2. Next one. In parentheses, I'm going to insert the -1. I see I don't really need the parentheses again, so I'm just going to ignore them and do the math, and it's 3. Last one. Again, don't need the parentheses. The answer is 8. So as you can see, my numbers are going up. As I increase x, the number that I get out increases. So when I input these, the outputs increase. That's very important to notice, especially when we get into linear equations in the next class. That's in the graphing class, if you're going to go on to the next class with me. It's very important to understand the relationship between input and output. That's how we communicate our numbers on a graph, is input and output. So keep that in mind, that relationship in mind. All right, let's do number 4. All right, evaluate the equation above when x equals a -1 and y equals a +1. So we're going to fill these into their appropriate spots, and it's going to be 3 times the -1, 2 times a 1. Notice I put the numbers I'm substituting in parentheses, okay? Now if I evaluate that, I can see that I do need the parentheses. So let's do the math now. 3 times a -1 is a -3. 2 times a 1 is a 2. If I take -3 plus 2, I'm going to get a -1. All right, 5 says to evaluate, same equation, and I'm evaluating it when x equals 1/2, so 1/2 goes into here, and y equals a -5, so -5 goes in for the y. So I'm going to fill in where the unknowns are with parentheses, put in my number that I'm evaluating for each variable, and then do my math. So I got to make that one a fraction. 3 times 1 is 3, 1 times 2 is 2, 2 times -5 is a -10. Okay, now to add them, I'm going to have to put a 1 underneath this, get common denominator, which means I'm multiplying this one by a 2 to get the same thing as the other fraction. And the answer is a -17 over 2. Or you could have written that as a mixed fraction, and that would have been 8 1/2, still negative. Or you could have written that as a decimal. Anyways, correct. That's not exactly what this class is after. We're not really looking to make sure you can do decimals and fractions. We're talking about the language So I'm not going to care if you write it improper, mixed, or um, or as a decimal. My biggest pet peeve would be is if you write it as a fraction, it has to be a reduced fraction. All right. So in number 6, we are still evaluating the same equation, 3x plus 2y, but this time x is equal to a negative 10, so that will go there, and y is equal to a negative 12, so that will go there. All right, so let's go ahead. I'm going to put my parentheses in until I evaluate if I need them. Just so happens because there's multiplication going on here and because we have a pesky negative, yes, they are very needed. All right, let's do our multiplication. We get a negative 30 plus a negative 24. Negative, negative. My answer is going to be negative. I'm going to add my numbers to negative 54. All right, let's do number 7. Okay, so number 7 is our algebra. So in some of my classes, I didn't get to this yet. If you were in one of the classes where I didn't get to the opposite operation, you can stop the video here. If you're in one of the classes where I did, keep watching, okay? Make sure that you did everything right and your steps are justified, and you'll be better for it. So let's look at this one. So in this one, we have multiplication going on, okay? 4x is being multiplied to the, negative 4 is being multiplied to the x. Now we got to look at what everything is doing to the x. So this 4 is multiplying the x. The opposite operation, let me put my opposite operation table up. The opposite operation of multiplication is division. So I'm going to divide both sides by a negative 4. All right. So over here I'm going to get the desired one that I need. So I drop down my x. And over here 4 can go into 28 7 times. I have a positive and a negative number, so my answer is negative. Alright, I always like to have my variable first, so I'm going to flip-flop these. I just got to take the sign that goes with it whenever I flip-flop. So this is going to be a positive t plus 7 equals 12. I just flip-flop the terms, okay? Alright, so I got to ask myself, what is the 7 doing to the t? Well, it's adding to the t, and the opposite operation of adding is subtracting. So I am going to subtract 7 from both sides. Okay, what I do to one side, I have to do the other. Plus 7 minus 7 gives me the 0 I need. Okay, so I'm just left with t. 12 minus 7 is going to give me 5. Alright, so in number, oh, that was number 8. Let's go ahead and put an 8 here. And let's fix this up. 9. Okay, in number 9, I have m minus 5 equals negative 10. Alright, so I have to ask myself, what is the 5 doing to the m? It is subtracting the m. So I am going to add to get that desired 0 on this side. And when I do to one side, I got to do to the other. So minus 0 plus 0 is, minus 5 plus 5 is 0. So all I have is m, because m plus 0 is still m. It doesn't change it. That has to do with our rules we talked about. So negative 10 plus 5 is going to give me a negative 5. Alright, so n plus negative 14 equals negative 31. This one's a little trickier. We got to ask ourselves, what is n doing? But we also want a 0, okay? And I have two signs here. So the first thing I want to do is clean up my signs. I know that a positive and a negative is always going to give me a negative. Now I can see clearly. Before it's like, the 14 is adding and it's subtracting the end. That is confusing. Clean up your signs. Always clean up your signs. Because now I can see that that 14 is subtracting the end. And the opposite operation of that would be adding. So I'm going to add 14 to both sides. Got to be fair because of that equal sign. It means I'm going to be equal. All right, so this is going to give me my big fat 0. Leave me with just an n. All right, and this is going to give me 17. And it's going to be negative because the bigger number is negative. Okay. All right, and number 11, I have L over a negative 15 equals 4. All right, so I have division going on here. Remember, a fraction bar means division. So the L is being divided by negative 15. So if I look at my little chart, the opposite of division is multiplication. So I know I'm going to multiply both sides by the negative 15 because I'm asking myself, what is it doing to L? And I'm doing the opposite of that. So that is what I have to multiply. Over here, these are going to cancel. They're going to make a 1. Remember, multiplication and division, ones do not change anything. 4 times a negative 15 is going to give me a negative 60. All right, number 12. In this one, the 3 is multiplying the y. So if it's multiplying the y, the opposite would be to divide the 3. That's going to give me my desired 1. What I do to one side, gotta do to that other side. And when I divide those, I get a positive 14. All right, that is all for day 1 of week 3. Keep practicing until it's second nature. Watch the video as many times as you need. I also have put a resource video that goes through everything all the way up to multi-steps. You don't need to know how to do multi-steps yet, but in this week we just do one-step equations. But watch until you're done with that. All right, I'll see you in class. Be sure to email me if you have any problems.